Now we come to soil resistivity. Okay?
Okay.
Okay. Soil resistivity. Let us go to the simplest one first. Is it simplest? The normal one. This is the common one, commonly used in the field, which is called Werner method. Werner method, you should have 4 probes instead of 3 probes before, or 3 electrodes. 3 probes. We should use 4 probes. One of them, 2 of them. This one is for the current source, and in the middle between the 2 current probes, you put the voltage probe and current probe. Now we have just open field, and we just want to measure the soil resistivity. So we just go to the field, just put one probe at one point, and the other probe for the current far away, and then in the middle between these 2 distance, or the 2 probes of current probe, we put voltage probe, injecting current into A. Correct?
Mm-hmm.
Okay, I put negative there. It means it's the same. Okay, it means current is going in. It's negative.
So this means the current has 2 directions.
Actually,
One
the
go to
current,
A and one up.
actually current goes to A, come back from D, go back. But if I put negative like that, also okay. Correct. Correct or not? If I can also do this.
Oh yeah, correct.
I can also do this. I go back here. It's the same, right? So I just put negative, so the arrow goes down. Okay?
Yeah,
so now you have 2 current source, which is into A and negative into D. Okay? You have 2 current source. One that goes into A. Your voltage is measured at B and C. Okay? So when you measure the voltage, you actually measure the voltage difference between B and C, meaning VB minus VC, or VBC. But VB is actually a contribution of 2 components, due to the current I at A and due to minus current I at D. Similarly, at point C, there are 2 components of voltage induced. First, due to the current I that goes into A, and secondly, due to negative current I that goes into D, will also induce some voltage into C. So now is find VBC, because if you find VBC, if you divide by I, you will get what the meter is reading, resistance. Correct? The meter will give always resistance only, or V divided by I. So now we know I, R is going to be displayed, but VBC is going to be measured. But you can also derive VBC theoretically. So to derive VBC theoretically, we need to say VBC is equal to VB minus VC. Correct? And VB is equal to VB due to I plus VB due to minus I. Similarly, VC is equal to VC due to I plus VC due to minus I. So David, now.
Sorry, Prof.
Huh? Okay. VBC divided by I is R. This is what we're going to measure. But we can derive VBC equal to VB minus VC. And VB, as I mentioned before, is due to 2 components, due to I and due to minus I. Similarly, VC is due to I and VC due to minus I. Now, Give me the equation for VB due to I. Equal to what? From your previous understanding. What is your previous understanding? This one. If you have a current going here, okay, you have a resistance to 0. Okay, so if the current is here, but your probe is here, VB, right? Then you need to find this distance X. And this distance X is the same. It gives you the same voltage. You understand? So, so this Vx is equal to VB. So you need to integrate from X to, this is infinity. You see? So this is resistance from X to infinity. Multiplied by I will give you VB. You understand? DC. And this is rho. The soil is rho. So give me VB due to I. VR, you need to integrate, because you need to integrate from X to infinity. It's not from 0 to infinity. So you need to integrate from X. And X now is A. Correct? A
Yeah.
to infinity. So do that one. I rho dr pi r square. Is it 2 pi r square? 2 pi r square. A to infinity. Right? Yes. So just do this. And then,
So it's I rho 2 pi A.
yes. So the answer is I rho 2 pi A. Okay. Now you have to repeat VB due to minus I. So remember, now you have to do the integration. So C is here. Your minus I is here. And you have to take the resistance from this distance. From this onward. Okay. Can you do it? I. What is the limit?
To A.
2A.
3A 2 2A.
2A. So now it's 2A, is correct. So now do the integration.
So it's I rho 4 pi A.
I. Are you sure I?
To infinity.
It should be minus, right?
Minus I. Minus I.
Minus I. Rho
Yes, minus I
4
rho
pi A.
4 pi A.
Okay. So similarly, you have to do VC also. VC due to I. And VC
Due to minus I.
due to minus I. Okay, can you do that one? So remember, C now is here. So you need to do C from A. C from A is like this. C from A is like this. See? C from A. And C from minus I is like this. So you know how the distance are. So just complete this one. So it should be I dr c due to I is 2a away. And the other one minus I dr because it's nearer to minus a, sorry, minus I, so a to infinity. So the answer is I rho
I
I roll 4 pi a.
4 pi a minus I rho 2 pi a, right?
2 pi a.
So now you can collect VB equal to I rho 2 pi a minus I rho 4 pi a. VC is equal to I rho 4 pi a minus I rho 2 pi a. Therefore, VBC equal to VB minus VC equal to, you need to minus this. Minus I rho pi a minus I rho 2 pi a, correct? Equal to
Yeah.
I rho 2 pi a. All right? Yeah, no, not.
I'm
Yeah.
trying to get the answer.
Yeah, that's the answer. Get it or not?
Yeah.
Okay, got it? Got it?
Yeah, I got it.
Okay, so now can you rearrange? Therefore, rho equal to? Okay, so this is Werner equation. Werner equation. If Werner equation is very simple, you have A, 4 electrode, two electrode for current, 2 electrode for voltage. Okay, like this, that's all. So Werner give you rho equal to 2 pi AR. Just the distance A required. And resistance measured, then you get the rho of the soil. Any question?
So far, no. So far, so good.